Did you know that the unit trips if bleed valves do not open within 11 seconds of the generator breaker opening during shutdown? In this module, you will identify the main problems associated with compressor bleed valves and explain the procedures and inspections you can perform to reduce system trips. At the end of this module, you will be able to identify the problems associated with compressor bleed valves that can cause system trips, identify the inspections and procedures that need to be performed to prevent trips that occur due to compressor bleed valve problems. It's important to keep track of the wide range of problems that faulty bleed valves can cause. Lack of surge control can cause complete rotor damage in extreme cases and, in all cases, can result in unit downtime if a trip occurs. Sticking is one of the primary problems associated with compressor bleed valves and can negatively affect the system's performance. If a bleed valve sticks open when the unit is running at more than 90% of base load, the unit alarm will sound. Sticking can be caused by a clogged vent screen, ice in the actuator or in the actuation tubing that carries the air supply, wear on the valve seat, or rust in the actuation system. Moisture, dirt, and oil are all in the vicinity of the actuation system. Therefore, the system requires regular cleaning and maintenance to prevent these contaminants from impacting the performance of the system. The solenoid's breather vent can get clogged and may cause a system trip. Substances that might cause a clog are too much water, freezing conditions, insect nests, and even dirt. If this vent is clogged, the valves may not open at the correct time and the turbine may trip. Inspect the vent to ensure that the air can freely flow from the vent port of the solenoid to the atmosphere. During shutdown, the bleed valves should open as the system de-energizes. If the valves do not open within 11 seconds of the generator breaker opening, the unit will trip. The trip is necessary to protect the compressor from operating in stall conditions during shutdown. If a trip occurs, perform the following inspection prior to restart. Inspect and test the VA2-1 through 4 valves to ensure proper actuation. Also check for leakage. If you can see shaft leakage through the packing box, tighten the gland nuts in half-turn increments until the leakage stops. Then inspect the tubing fittings to ensure they are not distressed or leaking. The continuous blowdown function of the system should have routine inspection performed to confirm moisture is running away from the actuating air lines. Any moisture buildup in the system must be allowed to drain. Inspect the 20CB-1 and 2 solenoid valves to ensure they function properly and are installed according to the applicable drawings. These valves provide actuation air to the bleed valves that must be installed precisely as indicated. Perform an offline valve actuation test using a portable compressed air source, 250 psia maximum, 80 psia minimum. Attach the compressed clean dry air source line to the 1-inch actuation air line at a location upstream of the solenoid valves 20CB-1 and 2 to test the system. You can attach the air line downstream of the solenoid valves to simply test the bleed valve actuation. Verify that the bleed valves actuate when pressure is applied to the line, approximately 50 to 60 psia. For units so equipped, inspect the FA6-1 filter and the continuous bleed orifice to ensure they are not clogged and are free to drain. They should be installed, per the applicable drawings, at a low point relative to the solenoid valves to prevent the collection of condensation in the tubing. For units in cold weather surroundings, the recommended procedure is heat tracing of the tubing, filter, and solenoid valves. It is also important that the actuating air lines slope to a low point to prevent them from freezing. Freezing of the solenoid or tubing can cause actuation issues with the bleed valves. During periods of extreme cold, condensation in the actuation air line can freeze inside the valve body, leading to slow or no actuation when required. Numerous valves have been returned to the supplier with burned or melted copper coils. Burned coils can cause the solenoid valves to malfunction, and as a result, the bleed valves will not actuate closed. The root cause of burned or melted coils is attributed to water entering the coil area from the conduit connection. The valve supplier is committed to supplying a sealant at this connection for future valves, but the 33 CB valves on the site should be checked for water. The valve may sit outside for some period of time before the conduit is run to the valve, and even when the valve has conduit threaded to it, the valve is still the low point of the conduit system. Power is fed to the solenoids via junction boxes and local 5-way enclosures to pick up the device leads for the solenoids. As designed, the 5-way enclosures are placed above the solenoids. Conduit then runs down from each 5-way enclosure to the electrical housing of each solenoid. The current design has moved the 5-way enclosures and the feeder conduit below the solenoids to prevent condensate in the conduit from flowing down into the solenoid. This rerouting makes the conduit the low point instead of the solenoid electrical housing. The site can use existing parts to perform this modification. You have reached the end of this module. In this module, you learn to identify the problems associated with compressor bleed valves that can cause system trips. Faulty bleed valves can lead to lack of surge control, causing complete rotor damage in extreme cases, and in all cases, unit downtime if a trip occurs. Sticking can be caused by ice in the actuator or in the actuation tubing, a clogged vent screen, wear on the valve seat, or rust in the actuation system. For units that provide high-pressure actuating air from the compressor discharge, the porous stone air filter FA6-1 can get plugged or damaged. The solenoid's breather vent can get clogged and may cause a system trip. Substances that might cause a clog are too much water, freezing conditions, insect nests, or even dirt. Compressor bleed valves are designed to be fully closed once the unit achieves full-speed, no-load conditions. Higher discharge pressures can cause a cylinder to move or change in shape, causing the disc to move in its seat and stick. Valves should open as the system de-energizes. If valves do not open within 11 seconds, the unit will trip. Coils burn or melt due to water entering the coil area from the conduit connection. Identify the inspections and procedures that need to be performed to prevent trips that occur due to compressor bleed valve problems. Regularly clean and maintain the system to prevent contaminants from impacting the system's performance. Periodically open the drain valve to blow the porous stone air filter FA6-1 down and visually inspect for dirt and contaminants. Inspect the continuous bleed orifice for clogging as well. Inspect the breather vent to ensure that the air can freely flow from the vent port of the solenoid to the atmosphere. To ensure the compressor bleed valve discs are in the proper position, perform the bleed valve stop bolt adjustment procedure. If a trip occurs, perform the following shutdown inspections. Ensure proper actuation. Inspect the valves for visible signs of shaft leakage. Inspect the tubing fittings for leakage. Confirm moisture is running away from the actuating air lines. Ensure the solenoid valves have been installed according to the drawings and are functioning properly. Perform an off-line valve actuation test. Inspect the FA6-1 filter and continuous bleed orifice to ensure they are installed properly and are not clogged. Perform heat tracing of the tubing, filter, and solenoid valves for units in cold weather surroundings. To prevent the problem of burned coils, move the 5-way enclosures and the feeder conduit below the solenoids to prevent condensate in the conduit from flowing down into the solenoid.